Good morning, grade 8 learners. Welcome to grade 8 Science Valenzuela Live, where learning science is fun and exciting. I am Sir V at your service from Vicente P. Trinidad National High School. Today, we will be exploring the wonders of electricity. At the end of discussing this topic, we should be able to infer the relationship between current and voltage. This topic shall be discussed for 2 sessions, so I am sure that you will learn a lot. For the first session, we should be able to do the following. First, define electric charge. Second, differentiate between static electricity and current electricity. Lastly, infer the relationship between current and voltage. Please prepare the following: your pen, your notebook, and your learner's module in science. So, these following materials. If you're ready, then let's get started. Right now, I am holding an inflated balloon. Beside me is my assistant, Sir Ian. Okay, I am going to rub this balloon on the hair of Sir Ian. What am I going to do next is to slowly move the balloon away from the hair. Observe what will happen to the hair as I move the balloon away from it. Are you ready? 1, 2, 3. That's it. Thank you, Sir Ian. Let us answer some questions based on your observations from the activity. First question: what happened to the hair as the rubbed balloon moved away from it? Second question: why does the hair behave that way? Write your answers in the comment section. Again, let us recall the events that was happened a while ago while I am rubbing the hair of my assistant, and then what happened as I move the balloon away from the hair. Later, we are going to find out if your answers are correct. We already know that objects in the universe are made up of matter. A matter is composed of tiny particles called atoms. Each atom is made up of subatomic particles. There are 3 types of subatomic particles: electrons that are negatively charged, protons that are positively charged, and neutrons that do not have charge. Protons and neutrons are located inside the nucleus, the central part of the atom, while the electrons are freely moving around the atomic nucleus. The overall charge of the nucleus is positive, since protons are positive and neutrons do not have a charge. On the other hand, negatively charged electrons surround the positively charged nucleus. These electrons can move from one atom or molecule to another. Most atoms have an overall charge of 0, since there is a balance of positive charge in the nucleus and negative charge in the electrons. But in certain circumstances, there can be an imbalance in the number of protons and electrons. This phenomenon causes the generation of electric charge. What is an electric charge? Electric charge is a physical property of matter that is affected by the number of protons and electrons in an isolated system. Electric charge is carried by subatomic particles. there are two types of electric charge: positive charge and negative charge. A positive charge occurs if there are more protons than electrons in a system. A negative charge occurs if there are more electrons than protons in a system. But sometimes, the term neutral is used to describe that there are equal number of protons and electrons in a system. It is important to understand that the term neutral is not a third type of charge. It is just a term that describes the absence of charge in a system due to equal number of protons and electrons. Now, let's practice identifying the charge of a particle. For example, we have three atoms named atom A, atom B, and atom C. Each atoms with the following number of protons and electrons. What do you think is the charge of atom A? Is it positive, negative, or no charge? How about atom B? And how about atom C? Write your answers in the comment section. Again, we have three given atoms: atom A, atom B, and atom C. Each atom has different number of protons and electrons. So, what are the answers for each atom? Is it positive, negative, or no charge? Okay, here are the answers. Atom A is negatively charged because it has more electrons than protons. Atom B is neutral since it has equal number of protons and electrons. So it has no charge. And then atom C is positively charged because it has, or the protons are more than the electrons. Before we proceed in learning the basics of electricity, it is important to remember that a charge of a system is being affected by the movement of subatomic particles, whether they are protons or electrons. These make subatomic particles an essential component of electricity. Each electron carries with it the elementary charge, which has a value of 1.6 times 10 raised to negative 19 coulombs. This magnitude is positive for protons and negative for electrons. Each system has an electric charge that is multiple of the elementary charge. In short, electric charge is quantized. Electric charge is a measurable quantity and it uses the SI unit coulomb. The term coulomb is used in honor of Charles Augustin de Coulomb, a French physicist who proposed that opposite charges attract and negative charges repel because of electric force, as stated in Coulomb's law. A while ago, I mentioned the term electric force. What is it? An electric force is a force that exists between two electrically charged particles. An electric force is also known as electrostatic force or Coulomb force. Let us look at Coulomb's law for us to further understand the relationship between electric force and electric charge. This is the formula that describes Coulomb's law. The variables used in this formula are F, which stands for electric force, K, which represents Coulomb's number that has a value of 8.99 times 10 raised to 9 Newton meter squared per Coulomb squared. Q, which represents charge, and R, which represents the distance between two objects. Coulomb's law describes that the magnitude of electric force between the two objects is equal to the Coulomb constant multiplied by the product of the charge of one object and the charge of the other object, divided by the square of the distance between the two objects. Coulomb's law states that electric force is directly proportional to electric charge. This means that as electric force increases, electric charge also increases. Coulomb's law also states that electric force is inversely proportional with the distance between the two objects. This means that electric force decreases as the distance between the two objects increases. It is important to remember that these electric forces can only flow if there is an electric field. An electric field is a field that surrounds each electric charge. This field is where electric force is being exerted towards all other charges in the field, whether there will be attraction or repulsion. What is the relation of electric charge to electricity? Electricity is a physical phenomenon that is caused by the behavior of electric charges in a system. There are two types of electricity. One is static electricity, while the other is current electricity. Static electricity is a stationary electric charge that occurs when there is an imbalance of electric charges within a surface of a material. This is typically produced by friction or rubbing two objects together. On the other hand, current electricity is a moving electric charge wherein charged particles are flowing through a conductor. We can classify materials based on their ability to transfer electric charge. A material that can transfer electric charge is called a conductor. On the other hand, a material that cannot transfer electric charge is called an insulator. Do you know any examples of conductors that are found in your home? How about insulators? The most common example of conductors are metals such as copper, gold, and aluminum. Some common examples of insulators include papers, plastics, styrofoam, and rubber. Now, let's go back to the first activity where I rubbed a balloon to the hair of my assistant, Sir Ian. What kind of electric charge behavior does the activity exhibit? Is it static electricity or current electricity? Write your answer in the comment section. Now, recall what we did a while ago. I had a balloon, I rubbed it on the hair of my assistant. After that, I moved the balloon away, then back to the hair, then move it away again. So, what have you observed? We already showed to you a while ago. My question is, what kind of electricity is shown in the situation? Is it static or current? If you answered static electricity, then you got the correct answer. The rubbing of the balloon to the hair generates friction and causes the electrons of the hair to transfer to the balloon. In effect, it generates an electric charge to both the hair and the balloon. My question is, in this situation, what is the charge of the hair? Is it positive or negative? How about the balloon? Is the charge of the balloon positive or negative? Write your answer in the comment section. So I am looking for two answers, by the way. So the charge of the balloon and then the charge of the hair. Is it positive or negative? Before rubbing, both the balloon surface and the hair surface have no charge. Each atom of both the hair and the balloon has an equal number of protons and electrons. As the rubbing starts, electrons of the hair move towards the atoms of the balloon surface. As a result, the hair surface has more protons than electrons, while the balloon surface has more electrons than protons. The correct answer in our previous question is this. The hair is positively charged because it has more protons, while the balloon has more negatively charged particles. So the charge is negative. Again, it is because the balloon has more electrons. Now, what are some real-life examples of static electricity that you know? Static electricity has several uses and applications like printing, painting, and dusting. Now, do you know that lightning exhibits static electricity? Lightning is a very powerful and dangerous example of static electricity in nature. It is being generated due to friction between ice crystals and graupel or snow pellets in a storm cloud. The lightning bolt that strikes the Earth's surface is a discharge of electricity due to overflowing static electricity buildup in storm clouds. This instantaneous discharge carries as much as 1 gigajoules of energy. Now, how much is that in terms of joules? 1 gigajoules of energy is equivalent to 1 billion joules. That's a lot of energy. Now, let's talk about current electricity. This is a familiar kind of electricity to us because we use this in our electrical devices at home. Current electricity has measurable properties that we need to study to understand how current electricity works. The first property is the electric current. We will talk about the other properties, voltage, and resistance in our next session. An electric current, or simply called current, is a stream of charged particles such as electrons that move through an electric conductor. The SI unit for current is ampere, which is described as the flow of electric charge across a surface at the rate of 1 coulomb per second. The name ampere is used in honor of the French physicist André-Marie Ampère, who is known as the father of electromagnetism. Current can be measured using a device called the ammeter. Now, how can we describe the flow of electric current in a system? Recall that electric charge is being carried by atoms that contain protons and electrons. In an electroconductive material, these charged particles move depending on the nature of the material. If the material is a metal, positively charged atomic nuclei are held in a fixed position, while negatively charged electrons are free to move about in the metal. If the material is a semiconductor like silicon and germanium, the charge carriers can either be positive or negative. If the material is an electrolyte, charge carriers can either be both positive and negative particles. A flow of positive charges gives the same electric current as of the flow of negative charges in the opposite direction. Since current can be the flow of either positive charges or negative charges, or even both, a convention is needed for the direction of the current that is independent of the type of charge carriers. The direction of conventional current is defined as the direction in which positive charges flow. On the other hand, negatively charged carriers such as electrons flow in the opposite direction of the conventional current flow in an electrical circuit. There are two types of electric current: direct current and alternating current. Direct current has a single flow of electric charge. Direct current is usually found in batteries and solar cells. On the other hand, the alternating current reverses its flow of electric charge many times a second at regular intervals. Alternating current is being utilized by electrical power plants to generate high amounts of electrical power and to enable the conversion of electrical voltage levels using transformers. Most wall sockets at home uses alternating current. Now that you have learned a lot for today's session, let us recap some of the most important pointers to remember. First, electricity is a physical phenomenon that is caused by the behavior of electrical charges in a system. Second, an electrical charge is a physical property of an object that is affected by the number of protons and electrons. Third, static electricity is a stationary electric charge, while current electricity is a flowing electric charge. Fourth, the electric force is directly proportional with the electric charge and inversely proportional to the distance between the two objects. Let us now answer some questions that our students sent us. So, Ian, thank you. Let me look first for some questions that we can answer today. And I think this would do. Okay, let me read first the question. Good morning, sir. Can we identify the direction of the current flow? If yes, how can we identify it? Okay, thank you for that question. So let me answer it. The answer is, it is difficult for us to identify the direction of the electric current flow because there are several factors that we need to consider. So some of those are one, the type of electroconductor, also the type of current, and we also need to consider the type of electric charge that flows in the conductor. And there are several other factors aside from that. Now, this is the reason why we are using convention. So a while ago, I said that there are two types of convention. So one is the conventional current flow, which describes the flow of positive charges. And we also have the electron current flow, which describes the flow of negative charges. Right? So I hope I have answered your question. Let me read now another question that we can answer. Okay, I think this would do. Let me read it for you class. Good morning po, sir. Which type of electric current is more dangerous? AC or DC? Thank you po, sir. Okay, thank you also for that question. So the correct answer for that question is actually electrical hazard has little to do with the type of current, whether it is AC or DC. Because an electrical hazard is primarily caused by high electric voltage. We will learn more about electric voltage in our next session. Now, what's more important is that both AC and DC can potentially bring hazards if it is not handled properly. So, always practice safety measures in handling electrical appliances. Now, if there are other questions that you want to ask, feel free to type in your questions in the comment section and I will do my best to answer your questions. That's it for our session today. See you next week for another episode of Grade 8 Science Valenzuela Live. Stay safe and have a great day.